section 1 of chapter 8, we're going to be talking about something called inverse variation, which is going to end up getting us into a whole new mess of things this chapter. You may remember from first semester, a handful of chapters ago, we talked about something called direct variation. And direct variation was a relationship between two variables, whereas one of them increases, so does the other. And our equation for direct variation looked pretty simple, just y equals ax. If x gets bigger, y is going to get bigger, right? And a was just some constant of variation, so maybe like y equals 2x. But if x increases, so does y. Or if x decreases, so does y. Okay, obviously if we make this bigger, then that product gets bigger, so y is bigger. Inverse variation is then the pattern or the relationship, whereas one of the variables gets larger, the other one is going to get smaller. So examples of that, as one thing gets larger, another gets smaller. The gravity, that's how gravity works. As the distance between two objects increases, the force of gravity between them decreases. Or in your class, as the number of distractions increases, the amount of learning going on decreases. Okay, so they're inversely related. If one gets bigger, the other one gets smaller. So there's two different forms that the equation for this could take on. A is just still the constant of variation. Okay, and then x and y are the variables that are related. So y equals a over x. If x gets larger, then we're taking this constant and dividing by a larger number, and that's going to make that come out to something smaller, right? Or if x gets smaller, then we're dividing by something smaller, so the piece we're going to have left is bigger. Alternatively, we could multiply that x to the other side, so xy equals some constant. If we're going to multiply two things and get a constant, let's say that constant is 10. If one of them starts to get bigger, the other one has to get smaller. So let's say we'd have, if x is 1, then y would be 10. But if we make x bigger, if x is 2, y has to get smaller. Y would only be 5, right? Or if we make x bigger to get to 5, then y has to drop down to 2. So inverse variation is just this pattern where as one gets bigger, the other's getting smaller. So the examples of things that we'll see in this section are very similar to what we did when we looked at direct variation. So on your notes you've got variables x and y vary inversely. When x is 8, y equals 3, right? The equation that relates x and y, then find y when x is 2. So the first thing to do to write the equation relating x and y is find what that constant is. So it tells us that x and y vary inversely, so we know that this follows that y equals a over x pattern. We know that y is 3 when x is 8, so we plug both of those in. We would multiply both sides by 8, and we find that a is 24. So the equation that relates our two variables, x and y, is y equals 24 over x. And if you were to put xy equals 24, if you want to use that form instead, that's perfectly fine. But this right here, writing that equation is a step that people often forget and they skip. They'll give me that a is 24, and then they'll just move on to this part. So it's a little step in between, but it's a pretty simple one. Just make sure that you write that equation. So then the last part, find y when x equals 2. So then all we have to do is plug in 2 for x. And when x is 2, y is 12. And that's it for inverse variation. That should seem very similar to direct variation.